Your next assignment is going to build on that work we did using logic gates in that big discussion of Boolean logic. We are now going to use semiconductor technology in the form of an integrated circuit to actually build a circuit that will provide us a Boolean logic function. One of the most basic ones, the AND gate. This is the chip that we're going to use. This is the 74LS08, also called the 74HC08. It is a quad AND IC, which means it's an integrated circuit that has 4 AND gates on it. If you had these physically, they're fairly robust, with one exception. Like all digital components, they are really susceptible to electrostatic discharge. So a tiny little bit of static electricity, remember that's very high voltage, low current static, the kind that you get when you pet an animal and then touch it on its nose, or you walk around on a carpet with wool socks on. That will immediately kill pretty much any integrated circuit that it comes into contact with. In the case of this quad AND IC, I think we're out 50 cents in bulk, $1 if you buy them one at a time. But the same electrostatic discharge is a problem for your $500 computer processor. So there are precautions you can take that will help to protect integrated circuits when you're working with them, most notably an anti-static bracelet and an anti-static surface to work on. The anti-static surface to work on is really beneficial. The anti-static bracelet really helps with electrostatic discharge, but it's actually more dangerous for you because by providing yourself as an immediate path to ground, anytime you touch the circuit, any electricity will travel through your body to the ground and could hurt you. Anyway, we're simulating, not an issue, so don't worry too much about that. Just some background. This is a particular type of IC called a DIP IC, or dual inline package. This is the package, and it just means that the pins are dual inline. There are 7 on the bottom and 7 on the top. There are several different types of IC packages, including the pin grid array, which we saw with processors. The dual inline is the cheapest to manufacture, so you'll see it a lot in ICs where size is not an issue. Okay, here's the pinout diagram for the 7400 series of integrated circuits. Something to notice. 2 things to notice. First, you need to make sure you have the chip oriented right side up. There are 2 ways you will know if it's right side up. The first of which is you can read the print when you are looking at it. And second, there's this dent here. It's over on the left-hand side of the chip. So when you're looking at the chip from the top down, the dent's on the left-hand side. This is the pinout configuration. It starts with pin 1 in the bottom left, goes up to pin 7 in a 14-pin chip. And here's the tricky part. Pin 8, the top row, is read from right to left. So it's pin 8 through 14 from right to left. So pin 14 is the top left, pin 7 is the bottom right. These pins are important because pin 7 needs to be connected to the ground of your circuit, and pin 14 needs to be connected to your positive voltage. In the case of almost all integrated circuits you're ever going to work with, that positive voltage has to be around exactly 5 volts. Which is why I like to use the Arduino as a power source, because it provides a nice clean regulated 5 volts. Okay, so this is the basics of the chips. You can see that this one has the pinouts drawn on it for AND gates. So if you look, pin 1 and pin 2 are inputs to this particular AND gate, for which pin 3 is the output. And that's what you're going to be wiring up. Here's the schematic diagram for the circuit you're going to build. It has 2 inputs. Now, remember, switches, we went through this before. Switches need a ground reference, which are provided by these 10 kilo ohm resistors here. So the switch, the input 1 and input 2, this is both plus 5 volts. Okay, the switches are momentary switches, normally off. You push them, they turn on. When they turn on, there are 2 conductive pathways established. The first of which is a conductive path to the ground that allows electrons to flow through the circuit, and then a conductive path from the switch side before the 10 kilo ohm resistor that connects to pins 1 and pin 2 of the 7408 IC. Pin 3 connects to the output. In the case of the circuit you're going to build, this output is going to be an IC, or sorry, not an IC, an LED, which will be protected by a 220 ohm resistor. Okay, here is the physical picture of the circuit you're going to build. 2 momentary switches here. These are the 10K ohm resistors that are prescribed here. This third resistor is the one that we use to protect the LED. It's a 220 ohm resistor. You're simulating it. You don't need to protect the LED, but you could, for a most accurate simulation of this real circuit, include it. Pin 1 and 2 are connected to the switches. Notice it comes after the resistor, after the switch, before the resistance path to the ground. And the chip is powered at pin 7, powered at pin 14, that's right here, and grounded at pin 7, that's right here. So this is the circuit that you need to build in Tinkercad. You can take a screenshot of it. You could share it with me, and I could tinker with it myself, but really all I need is a picture to know that you did it. So this is your assignment for the remainder of this week and probably into next. We are going to work with some more 7400 series ICs that are going to make circuits that do different things, and we are going to combine some of this together to make a circuit that actually is really at the basis of all the computing that you do. So as always, guys, if you have questions, feel free to email them to me. I'm tawilson@hwdsb.on.ca, and I am really bored with the pandemic, so I'll respond right away.